This is section 11.1, part 2, theoretical probability. In the last section, we determined how to find probabilities under experimental situations, which was called experimental probability. Now we're going to learn how to determine equally likely outcomes and how to calculate theoretical probability expected. So, under a model, if each outcome of an experiment has the same chance of occurring as any other outcome, they are said to be equally likely outcomes. For equally likely outcomes, the probability of event E may be calculated with the following formula. The probability E equals the number of outcomes favorable to E divided by the total number of possible outcomes. The total possible number of outcomes we will find out is called the sample space. So, in determining probabilities, a die is rolled. From the probability of rolling, what is the probability of rolling a 5, an even number, a number greater than 3, a 7, a number less than 7? The first step is we're going to write the probability statements first. So, let x equal the probability of a number x on a die. So, in the first example, we have the probability that x is equal to 5. If we have the probability of an even number, we have the probability that x equals 2, x equals 4, or x equals 6. A number greater than 3, the probability that x is greater than 3. And finally, a probability of a 7, probability that x equals 7, or the probability that x is less than 7. Okay, so let's find these probabilities. So, in our first example, the total number of outcomes that will result in a 5, well, that can only happen one way on a die, and the total possible number of outcomes is 6. So it's 1 over 6 is our solution. For part B, rolling an even number can occur in 3 ways. It can occur in 2, 4, or 6. So there are 3 possibilities out of 6. So rolling an even number is 3 over 6, or we reduce it down to 1/2. So this next solution is 3 numbers are greater than 3. That's 4, 5, and 6. And again, that means that p greater than 3, there's 3 numbers divided by 6 possible ways, which is 1/2. Finally, no outcomes will result in a 7. Thus, the event cannot occur, and the probability is 0. 0 over 6 equals 0. Finally, all the outcomes 1 through 6 are less than 7. Thus, the event must occur, and the probability is 1. So a number less than 7 is 6 over 6, which equals 1. So here's some important facts about probability. One is the probability of an event that cannot occur is 0. The probability of an event that must occur is 1. Every probability is a number between 0 and 1, inclusive. That is, for any probability of an event, the probability is between 0 and 1. The sum of the probabilities of all possible outcomes of an experiment is 1. These are the two rules of probability, and we talked about them in class. So, because the sum of the probabilities equal 1, the probability of A plus the probability of not A has to equal 1. We call this the complement. So not A is the complement of A. Therefore, the probability of not A is equal to 1 minus the probability of A. So we're going to select one card from a deck. A standard card of 52 playing cards is shown. As you can see, we have hearts, clubs, diamonds, and spades. The numbers range from ace all the way up to king. There are 13 cards in a suit, and there are 3 face cards in each suit. Again, the deck consists of 4 suits: hearts, clubs, diamonds, and spades. Each suit has 13 cards, including numbered cards ace 1 through 10, and 3 picture cards or face cards: the jack, the king, and the queen. Hearts and diamonds are red cards. Clubs and spades are black cards. There are 12 picture cards or face cards, consisting of 4 jacks, 4 queens, and 4 kings. One card is to be selected at random from the deck of cards. Determine the probability that the card selected is a 7, not a 7, a diamond, a jack or queen or king, a heart and spade, a card greater than 6 and less than 9. So if we select one card from a deck and we're asked to find the probability that the card is a 7, right? We have the probability of x equals 7 is 4. There's 4 sevens in a deck of cards divided by 52 cards, which is equal to 1 over 13. Not a 7 is the complement of the above result, which is 1 minus the probability that x equals 7. In this case, we have 1 minus 1/3, 13, which is equal to 12 over 13. We can always put all of these in decimal points, and sometimes it's necessary to do that to find percentages. So now we want to find the probability that the card selected is a diamond. There are 13 diamonds in the deck, so therefore the probability that we have a diamond is equal to 13 over 52, or 1/4. So now if we select one card from a deck, we want to know the probability that it is a face card. Since there are 4 jacks, 4 queens, 4 kings, or a total of 12 picture cards, we have the probability of a face card is equal to 12 over 52, which is 3 over 13. So now we're asked to find the probability of a heart and a spade. The word "and" means both events must occur at the same time. For one card, it's not possible. So one card cannot be both a heart and a spade. So the probability has to be 0. So in this case, the probability of a heart and a spade is equal to 0. And we want to finally, we want to select one card from the deck where the card is greater than 6 and less than 9. The cards are both greater than 6 and less than 9. That means that there are 4 7s and 4 8s, and the total has to be 8 of those types of cards divided by 52, which is 2 over 13. So the probability that I get the card drawn between a 6 and a 9 is approximately 2 out of 13. Now, suppose we toss a fair coin 3 times. Find the following events. List the sample space. Find the probability of getting 1 head. Find the probability of getting no heads. So in this case, we will find the sample space. Here we are going to list them out. We can get heads, heads, heads. We can get tails, tails, tails. We can get heads, tails, tails. We can get tails, heads, tails. We could get tails, tails, heads. So that completes 1 head, and then we can get head, head, tail. We can get heads, tails, heads. And finally, we can get tails, heads, heads. So there is our sample space. There's 1, 2, 3, 4, 5, 6, 7, 8 possibilities. Now it says find the probability that we get 1 head. X is the number of heads, and so the probability of getting 1 head is equal to 3 divided by 8. Well, how's that possible? Well, there are 3 events, or 3 outcomes that have just 1 head. Then it says find the probability of getting no heads. Well, that is just tails, tails, tails. So the probability that x equals 0 is got to equal 1 over 8. Why? Because we only have one possibility of tails, tails, tails. So in summary, for Chapter 11.1, we define the probability of an outcome or an event in 2 ways, empirical or theoretical. Probability has 2 major rules. The sum of the probabilities is equal to 1, and each probability calculated is a decimal between 0 and 1. Finally, the complement of the probability of an event is 1 minus the probability of the event. So that concludes our Chapter 11.1 on basic probability ideas. Our next chapter we're going to discuss is talking about expected value.